Section 3.2. The first rule we're going to be looking at the derivative of any constant, d dx of any constant, that's another way of writing the derivative, is always a zero. The derivative of any constant is a zero. So what's the, bless you, what's the derivative of 7? 0. What's the derivative of 0? What's the derivative of minus 50? 0. So the derivative of any constant is 0. We looked at that early. The other one, the derivative of x to the n is what? N times x to the power of n minus 1. The derivative of x to the fifth is what? 5x to the fourth. The derivative of x to the third, 3x squared. The derivative of x to the minus 2. Think about this one.
Negative 2x to the minus 3.
Yep, very good. Take the power, negative 2, move it to the front, and subtract 1 from the power. What's minus 2 minus 1? Minus 3, not a plus 1 or a minus 1. You're subtracting 1 from the power, always. What's the derivative of x to the power of 1.2? Doesn't have to be a whole number. 0.2 x to what power? 0.2. Yep. Ready for the next one? Using that rule, what's the derivative of x?
1.
Why 1?
Because it's going to be x to the 0.
Very good. Because the power of x right now is what? 1. We just don't put it. There's a 1. We just never put it there. So you move your power to the front, which is 1, and you subtract 1 from the power. And anything to the 0 power is what? 1, so your answer is 1. So the derivative of x is always a 1. So if I want to add that to my list of rules here, I still have that sheet handy. Rule number 3. I'm trying to change the looks. The derivative of x is equal to 1. Add that to the list. Now we get 3 of them. Ready to try a few of them? You try it. What is the derivative of x to the third? 3x squared is the correct answer. Not bad. What's the derivative of the square root of x? Perfect. How'd you come up with that answer? Yep, it said the square root means x to the power of 1/2. Isn't that what the square root? So that will be what? 1/2 x to the power of what? Minus 1/2. If you don't like negative exponents, you can make it 1/2 1 over x to the 1/2, which is what? 1/2 times 1 over the square root of x, which is 1 over 2 the square root of x.
So what if you had this, the derivative of the square root of x plus 1?
Coming up. Is the plus 1 inside the square root or outside the square root? That's a different story. You won't get that today.
But it's on the homework.
You got to do it the long way. Yep. Yep.
What if it has 8 over radical x?
You got to rationalize it. Yep. 8 over x. No, actually, you can do the shortcut for that. Because if you had that problem, I'll change it. 7 over the cube root of x. The cube root.
Come on, don't change it like that. Just do 7 over.
No, 7 over the cube is a better one. Got to think there. God put me on this earth to aggravate people. Make sure you know it.
Serving your purpose there.
You can rewrite that problem as what? 7. Okay, how do you write this one?
7 over x to the 1/3.
Okay, x to the 1/3 in the bottom. Can you bring it up to the top? We didn't cover that rule yet, but when you have a number in the front, it's not a big deal. Leave that number alone, the 7 alone. What's the derivative x to the minus 1/3?
Minus 1/3 x to the 1 and 1/3.
Is it 4 over 3?
Right, yeah.
Yep. So you move the minus 1/3 to the front, and you subtract 1 from the power. Minus 1/3 minus another 1, that's negative 4/3. So now just do your algebra. What's 7 times a minus 1? Negative 7 over 3.
Why wouldn't that be 0, the 7?
Oh, no. It's not the derivative of the 7. This is multiplication. I said that rule is coming up in a few minutes. When you have a multiplication, like 7 times that, the rule is not the derivative of the 7 times the derivative of that. Nope, no. That's, you can pull the 7 outside to the front. I just jumped the gun because she asked that question. You can pull it in the front and take the derivative of that. So that becomes 1 over x to the 4/3. And if you don't like this, you can write that negative 7 over 3 times 1 over the cube root of x to the 4th. Hopefully you know how to simplify the cube root of x to the 4th.
You successfully did not have the answer to that problem.
Good. That's the cube root. X to the 4th is what? X to the 3rd times x. That's what x to the 4th. And if you know about radicals, you can break it down to 2 parts. When you have multiplications. What is the cube root of x to the 3rd? X times the cube root of x. So if you plug that in here, your final answer becomes negative 7 over 3x, the cube root of x.
Can you slide that up?
So let me give you the rule. You asked me, well, how come the derivative 7 is not 0? Because that's one of the rules. Add that to that list. Rule number 4. If you want to find the derivative of some constant times a function, constant times like 7 times x to the 4th, the rule says you can take that constant outside, multiply it by the derivative of that function. So that's the rule there. When you have a multiplication or division, because division is multiplication by a fraction, so dividing by 7 is the same as multiplying by what? 1/7. So that applies really multiplication and division. So when you see something,
Wait, does that mean you can do it or you have to do it?
which one?
The constant times a function, taking the derivative of the constant times.
If I have, I'll just give you some example and see if that makes sense before I answer your question. If I say, what's the derivative of 8x squared? The rule says you can take the 8 outside times the derivative of x squared. What's the derivative of x squared? 8 times 2x, which is what? 16x. Now, a lot of people don't want to go through these steps, or they can do in one shot. And that is, what's 8 times 2?
16.
And subtract 1 from the power. Instead of doing it this way, you go 8 times 2, 16, and subtract 1 from the power. It's always going to be the same answer. Watch another one. 7x to the 9th. The long way, the rule says you can take the 7 outside times the derivative of x to the 9th. What is the derivative of x to the 9th? 9x to the 8th. Move the power to the front, subtract 1 from the power. 7 times 9, 63. X to what power? 8. Again, you could have done that in one shot. What's 7 times 9? 63, subtract 1 from the power, x to the 8th. So that's the direction you're going to see me go with all of these instead of doing all these 4 or 5 steps.
How come you can't do, if you're taking the derivative of 7, why can't you just do 0 times 9x?
You'll see that. That's called the product rule. That's coming up in the next section. It's not the derivative of this times the derivative of that. Doesn't work that way.
We're looking at it as one whole.
Yep.
thing. Right, okay.
You can use the product rule when you get to that, and after 6, 7 steps, you end up with the same answer. But if it's multiplication, you can't break it down. You can only break it down if it's addition and subtractions. And that's actually the next rule. If you have addition subtractions, you can break it down, but not multiplications. If you have addition or subtractions, doesn't really matter, you can break it down the derivative of the first, and if it's addition, you leave it addition. If it's subtraction, you leave it subtractions. The derivative of the second. If you have a fraction, you can't do that. The derivative of f over g is not the derivative of f over the derivative of g. It doesn't work that way. The same thing with multiplication. If you have something times another one, you can't take the derivative of the first times the derivative of the second. It only works if it's addition subtractions. So let's try some of these examples. What's the derivative of x to the 9th plus x to the 7th minus the 6th. The rule says when you have addition subtraction, you can take the derivative of the first, which is what? 9x to the 8th. If it's addition, you leave it addition. What's the derivative of the second one? There's the minus. What's the derivative of 6? So your answer is what? 9x to the 8th plus 7x to the 6th. What's the derivative of 10x to the 4th plus 8 over x squared minus 5 the square root of x? You're having fun. Why not? Well, if you rewrite that, this becomes 8x to what power? No, this one. Minus 2, yes? This is minus 5x to what power? 1/2. Now let's take the derivative of each one of them. What's the derivative of 10x to the 4th? A shortcut. 40x to the 3rd. What's the derivative of this one? Minus 16x to what power? Negative 3. Subtract 1 from the power. Minus 2 minus 1 is negative 3. The last one? Or 5 over 2, or 2.5. Yep. X to what power? Negative 1/2. Very good. Now again, if you don't like negative exponents, you can rewrite that, what? 16 over x to what power? 3rd minus 5/2, and this will be 1 over x to the 1/2, which means what? Square root of x. If you don't like to make this two fractions, make it a one fraction.
And that's all just personal preference, right?
Well, yeah, or the software will say leave the answer with negative exponents, or do this, do that.
Is it
Yes.
that last one that you're coloring on right now? Could you make that 5 over 2x to the 1/2? Is it the same thing?
In the bottom?
Yeah.
2x to the in the bottom, yes, you can write 2x to the 1/2 in the bottom. But they probably will not leave it that way, Nick.
No.
They probably make it the square root of x.
Oh, okay.
But a lot of books don't like to see square roots on the bottom. So if they don't like to see a square root in the bottom, what you might see them do, and again, I'm just wild guess here, I have no idea what our software wants. If they said rationalize your answer, you multiply the top and the bottom by the square root of x to get rid of the square root in the bottom of this one.
Okay.
So your answer will be 40x to the 3rd minus 16 over x to the 3rd here. And this will be what? 5, the square root of x over what? What's the square root of x times the square root of x? X times the 2, 2x. So you could see it looking like this. You could see it looking like this, like this, like that. I have no idea which way they want it. Let's have you try color these. Hey, I forgot to put on vibrate. F of x equals x cubed minus 4x plus 5. What's the derivative of that?
Three x squared minus 4.
Minus 4?
Yeah.
Okay. Because what's the derivative of x?
Uh,
1. Yep. So 4 times 1 is 4. What about the 5?
0.
0. Good. Let's try another one. I'm going to change the notation a little bit so we keep mixing and matching here. What's dy dx?
What is it, 5?
That's a 5. I was about to write 4, so I'll change it to 5. The other one was 4. Yep. What was it? 6x. 3 times 2? 6x. Minus the derivative of 5, which is what? 0. What is the derivative? Of negative x to the 4th over 2 plus 3x to the 3rd minus the 2x. I'm sure the second third is not a problem. What about this one?
Wouldn't that be minus 4x cubed raised to negative 5? No?
What's that number in the front means?
Minus 1?
Is that minus 1/2?
Yeah. Wait, how's it minus 1/2?
Dividing by 2 is the same as multiplication by 1/2. There's a 1 here. We just don't put it.
Right.
So now let's take the derivative of that. Four times a 1/2. It's going to be a minus first. What's 4 times a 1/2? 2x to what power? 3. Good. That'll be what? 9x squared minus what? Minus the 2. Good. I think you're in the hang of it.
This is section 3.2.
Yes. That's all you're seeing today, section 3.2. These we have to memorize. Ready for them? The derivative of sine of x. Derivative sine of x is equal to cosine x. The derivative of cosine x. It's negative sine of x. The derivative of tangent x is equal, do we cover them actually in this chapter here, in this section? They didn't cover it yet in this section, but it's secant squared. In this section, I didn't see it yet. They'll wait on it. It's coming in the next section. But these are actually covered in this section. The other one you need to know that's covered in this section, and that's the derivative e to the x. E to the x is equal e to the x. It doesn't change. I like that one. So those three for now with the red check mark next to them are covered in this section. This one you can wait on it. That's the answer to it, but you can wait on it. Let's try some examples on that. The body language, I don't like what I'm seeing. Everyone's like, ah. Let's take a few problems. Tell me the derivative. What's the derivative of that? What is it? 3e to the x? Remember, you can take the number in the front. There's the number. What's the derivative of e to the x? Still e to the x. What about if we have this problem? F of x equals x squared minus e to the x. What's the derivative of that? Plus 6. Let's just have fun here. 2x minus e to the x. What about the plus 6? 0. Good. Next one. F of x equals sine of x minus 4 times cosine x plus 3e to the x. The derivative of sine is what? Cosine of x. Now there's the minus 4. Let's go slowly with it. What's the derivative of cosine x? Minus sine of x. Okay. Plus, there's the 3. What's the derivative of e to the x? Can we clean it now? It's cosine of x. 4 sine of x, yep. Plus what? 3e to the x. So we just have to memorize the derivative of sine's cosine. Derivative of cosine is negative sine. Now, one of the restrictions when you decide to come to engineering, especially when you take physics, all engineers take physics, so you can't take physics till you take calculus 1. And if you try to sign up for physics, I say no, university physics I'm talking about. Because when we talk about velocity, that's the derivative of the distance. Acceleration is the derivative of the velocity. So we start talking about derivative there, and if you never had calculus, you can't. Since we're going to bring in physics here a little bit, but we're doing the average rate. So for example, we might have, if you're dropping something, and I'm looking at the equation, I can tell you what that means. You're on top of a building. The building is 100 feet high. You got a water balloon in your hand. There's a water balloon. And you see your math teacher walking out of the building. Just had a test and you just want to hit them. You take the water balloon, you can hit it at them straight down, or you can drop it. Let's say you dropped it straight down. You didn't hit it down. If you just drop it, then the height of that water balloon at any given time is called S, as a function of time, is going to be negative 16 t squared plus 100. Where's the negative 16 coming from? You don't have to know the physics behind it, but where do you think it's coming from? Gravity. It's 32 feet per second squared. Now, if you take it and throw it down at 5 feet per second, then there's an extra term. It will be negative 16 t squared plus 5t plus the 100, whatever the initial velocity. You know. So the standard form is always, in physics, that's the negative the acceleration divided by 2 times t squared. Negative because gravity is pulling down. If you throw it down, the velocity is negative. If you throw it up, the velocity is positive, but there'll be plus v0t, initial velocity, times the time, plus the initial height. O for initial, we always use in physics. But that's where the equation came from. Do you have to know that? No.
Why is
because gravity is pulling down. So we use up is positive and down is negative. So when you throw the ball down at me, that initial velocity would be a negative number.
So would it be negative 9.8?
Well, that's if you're using meters per second squared. This is feet. You know. Again, we don't have to know where the equation came from, but sometimes it's nice to see where the equation came from. But for this class, it's not important. The question, find the average velocity. Average velocity as the water balloon goes from, I don't know, let's give some numbers, from 1 to 2 seconds. So 1 to 2 seconds. Find the average velocity. Well, average velocity, or the word average, if anything, is the rate of change, which is the change in s over the change in time, distance over time. Change in the position over change in time. That's what the velocity, or average velocity. The change in distance, I'm only interested as you go, this is the 1 second here, and this is the 2 second. I need someone here with the camera that will give me the speed of that object as it goes by this, and the speed right here. So, the position. So the average velocity is going to be the distance at 2 seconds here minus the distance at 1 second divided by the time, which is 2 minus 1. So what is my distance at 2 seconds? Plug into this equation. You let S be 2 here. That's 4 times 16, negative 64, plus 100. That's 100 minus 64, right? Whatever that number is, we'll come back to it. What about the position, the height at 1 second? That's 100 minus what, 16? Over 2 minus 1, which is 1. What's 100 minus 64, we said? 36. Minus, what's 100 minus 16? 84. Divided by 1. Is that negative 48, somebody said?
Yeah.
What's the negative means?
It's falling down.
Falling down, because plus is positive, negative. So negative means it's moving down. So that's how we calculate the average velocity. It was moving at the rate of 48, average speed of 48 feet per second at that time. As you travel down, guess what? That number becomes larger and larger. It's moving faster. Your velocity down here will be a lot larger than negative 48 and 48. So that's how we calculate the average rate of change of anything. If it's velocity, we take s at 2 minus s at 1 divided by 2 minus 1. If these numbers were 5 and 6, we go s at 6 minus s at 5 divided by 6 minus 5.
Are we gonna look, are we gonna be seeing a question like that on chapter 3 test?
No. On chapter 3, I mean?
Yeah.
I don't know, I didn't get that far. We'll talk about that later. I think I'm in chapter 2 test.
Oh, no.
Yeah. It might be 1 or 2 on the homework, but I don't know if you'll see them on the test. If I say what's the average, again, the same problem, or I'll give you a different problem. Let's say S, the height was negative 16t squared minus 10t plus 50. This is the equation. And what is the average velocity? Let's make that 500. You're on top of a really high building, because I'm not sure if these numbers going to be, it's moving fast. If I go average velocity as you go from 4 to 1 second, or 1 to 4 seconds, not 4 to 1. 1 to 4. as the time goes from 1 to 4 seconds. The average velocity is going to be the position at 4 seconds minus the position at 1 second over 4 minus 1. I need to plug in my position of 4 seconds. Plug it into this one. What do we have? What's my height at 4 seconds? 16 times 4 square. Well, negative 16 times 4 squared.
Negative 256.
Okay, negative minus 40, right? Plus the 500. Like I changed that to. So my height at 4 was, what was it? 204? Is that what you got?
Yeah.
What is my height at 1 second? I got 474 divided by 4 minus 1. So 204 minus 474, it's negative 270 divided by 3, which is what? Average speed of negative 90 feet per second. Now you're moving faster. Negative 90 feet per second. Different problem. I also took that balloon and I gave it initial speed in this direction of 10. So it will move faster. But the average speed, which we know changes from spot to spot, over that period from 1 to 4 seconds, we were dropping at the rate of 90 feet per second. That's what that means.